When we're talking about the elimination of alcohols, it can get a little bit confusing because the reagent we use is sulfuric acid, but in this case it's concentrated. Okay, so what happens if we have something simple like ethanol? So there is our alcohol, and we add concentrated sulfuric acid to it. We get an elimination, so we remove some things. So we remove the alcohol group, but because we can't just remove that, we need to remove something else as well. If we take away that H, we end up with a side product of water, and that then leaves us with two free half bonds here. Okay, so if we've got two free half bonds, this should be initially what we were left with. But this is extremely unstable and can't stay like that, so we end up with a double bond forming here, and we end up with an alkene. So when you use concentrated sulfuric acid, you have an elimination reaction. You take off an OH and an adjacent hydrogen from, a carbon hydrogen from a carbon adjacent to the OH, and you end up with an alkene. Now this gets a little bit more complicated when we are talking about asymmetrical, not symmetrical alcohol. So these are secondary or tertiary alcohol. So if we look at something like this, so if we look at something like butane-2-ol, I'll just draw it out twice. Okay, so there is two possible products. So we have something called Zaitsev's rule or anti-Markovnikov's. I'm just going to pause the video here for the train. Sorry about that. Right, so when we react this with concentrated sulfuric acid, Zaitsev's or anti-Markovnikov's rule states that you're still going to remove the OH, but you're going to remove the second hydrogen from the carbon with the least number of hydrogens already attached. So these are your two adjacent carbons. If you look at this one has three. This carbon only has two. So in the majority of situations, you're going to remove this hydrogen here. So you end up with this as your product, and you get your double bond forming in the middle here. So that is your major according to Zaitsev's rule. Of course, that doesn't happen all of the time. So if you look at this one here, if we take an OH, sometimes, not as often, but it still happens, we actually end up having to remove, or it takes the hydrogen from the carbon with that has more hydrogen. So this one has three, so it takes the hydrogen from there. So you end up with butane-1-ene. Okay, so that is elimination reactions and Zaitsev's rule.